This is the second in a series of tutorials on TK solver and thermodynamic and fluid property calculations. The fluid properties functions, again, are found in the wizard's menu, the navigation bar. And there are various functions here that can be used. If we're going to do different calculations, I was going to show you how to create a mixture. Go here, define a new mixture. Pick the different fluids that you want in the mixture. Indicate some variable for the fraction of that material in the mixture. You can have as many components in the mixture as you like. Then the wizard automatically creates the string connecting all the different text that goes into building the substance, the mixture parameter. Again, I'll mention here we'll use T and P as the variable names for the temperature and pressure. My build rule, you can see the expression now used to combine butane with fraction A with propane with fraction B and embed that into the density calculation. I click OK. It places that expression here. Set that equal to a variable. I'll add a rule that combines the two fractions, says it has to be equal to 1. If I have 0.35, 35% butane, and we'll put this mixture at 400 K, 105,000 Pascal, calculates the density of the mixture. And because it's part of a TK solver model now, we can use any of the different solvers available in TK. For example, let's say I need the density to be 1.525, and I want to know what the mole fractions have to be in order to make that happen. I can indicate that we need an initial guess for A, and when I solve, it iterates and finds the values of A and B that make the density 1.525 when we have this temperature and this pressure. So it's another nice block that you can use in your mathematical models. You can take any of these density functions, make them part of a math model, solve them forward and backward, even building your own mixtures and things like that in. Another feature that comes with the TK solver related to thermodynamic functions is the refprop utility that comes from the NIST group. Refprop comes from the NIST group. They're the ones who develop the built-in functions that we use in TK solver. And refprop allows you to look at properties outside of TK solver, generating plots and tables of solutions so that you can study things independent from the math model itself. We'll take a look once and see how this works. The first thing you do is you specify the units you want to work with, which properties you want, other preferences. For properties, you pick all the ones that you want. And these correspond to those functions that are available from within TK. But these allow you to see all these functions simultaneously in a single grid. We'll take a look at that in a second. You pick your substance. So if I take, for example, benzene. And we now want to calculate a specified state point. You see that all those variables appear here in the table. So at a particular temperature, I'll just say 75 degrees C, and the pressure in kilopascal, we'll say that's 1500. So at this temperature and this pressure, we see that the benzene has this volume, this enthalpy, quality is subcooled. You get it all within a grid here. It doesn't allow you to back solve like you can in TK, but it is nice. It's a way of understanding a little bit more about the different properties. It also lets you create plots. So for example, we might want to see a TS diagram for this. Set up all the parameters for the plot here, and it generates the plot with a click of a button. That ends this tutorial video.